Morning. Right, so we talked about this the other day. The fact that frequency is inversely proportional to length. So if you increase the length of the string, you will decrease the frequency. We talked about frequency being proportional to the root of tension. So for a big increase in tension, you get a smaller increase in frequency, as in if the tension increases by a factor of 9, the frequency will increase by the root of 9. So it will increase by a factor of 3. And then the last one was the mass per unit length, which is essentially the mass of the string. So if you were to measure the mass of one unit length as a meter, so if you measure the mass of 1 meter, that's mu. So it's inversely proportional to the square root of mu. I said this the other day, I have it written here as well. We don't investigate that third relationship, we only investigate the first two, so we will do that experiment when I'm back. Now, we can throw this all together, like smush all three of these relationships into one equation. So you can see I've done it here. So frequency is on the left. I have it inversely proportional to length. So length is on the bottom. It is proportional to the square root of tension. So the square root of tension is on the top. And inversely proportional to the square root of mu. So the square root of mu is a denominator on the right hand side. Yeah? So if we mush them together then, the square root of tension over the square root of mu, the two roots can go together. And we end up with this here. And then this is a proportionality. So if we want to use it as an equation, we have to introduce a constant. So I've turned the proportional into an equals, and the constant is k. And it's not on our course to prove the value of k, but k equal to half. So if you make k equal to half, you get this. Okay, the fundamental frequency of a stretched string is given by 1 over 2L, the square root of T over mu. All right, so I'll do one question here for you. Yeah, second one's fine. And I'll just give you a few questions to do. This is obviously in the Formula and Tables book, so it doesn't need to be learned off. As well as that, it helps that you don't need to learn off the relationships. Provided you can read this formula, you can look at like frequency is a numerator, length is a denominator. So they're inversely proportional. Frequency is a numerator, and then the root of tension is a numerator, so they're proportional. Do you know what I mean? So the formula is in the Formula and Tables book, and you don't need to learn off any of the relationships. So a wire of length 3 meters has a mass of 0.6 kilograms. It's stretched between 2 points so that the tension in the wire is 200 newtons. Calculate the fundamental frequency. So F is 1 over 2L, the square root of T over mu. Okay, so the length is 3 meters. The tension is 200 newtons. Now, mu, remember, is the mass of 1 meter. So they tell us here that 3 meters has a mass of 0.6 kilograms. So that means 1 meter, if we divide this by 3, we'd have to divide this by 3. So 1 meter is 0.2 kilograms. So I can put that back in. 1 over 2 times 3 square root of 200 over 0.2. And then that's it. Just throw that into your calculator. Multiplied by 1 over 6. Sorry, just going to double check I did that right. 1 over 2 times 3 square root fraction 200 over 0.2. Yeah, 5.27, and it's a frequency, so hertz. Is that all right? So I am going to get you to do a couple of these. I wanted, right, so 2, 4, 5 and 6. Right, so give those 4 a go. Will you put your solutions into your folders? So each one of you will have this folder with the 4 pages. Whenever you do your homework, just put it into the homework folder and just put today's date on it. So the 27th. Is that all right? I will be checking. Well, I suppose, yeah, it'll be due for. Oh my God, when do we have class next? Is it when? Anyway, whatever your next class is, because we're off Monday and Tuesday. So whenever your next class is, that's when they'll be due for. All right? Okay. Thanks, guys.